Assalamu alaikum dear students. Today we are going to discuss and solve the numerical problems of chapter number 18, the dawn of modern physics. So in the first numerical they are talking about the length of spaceship is measured to be exactly the 1/3 of its proper length. So what is the speed of spaceship relative to the observer? So in this numerical problem the given value is L equal to 1/3 of proper length, and we have to find speed of spaceship, which is equal to v. So the equation for this problem or formula for this problem is the relativistic equation, which is known as formula for the length contraction. So for the length contraction we have a formula which is relativistic equation for the length contraction. So L equal to L naught under the root of 1 minus v square divided by c square. So now it is easy to understand and solve. So we have a given L and we have a formula. So if you can see, so the value of L, which is 1/3 L naught, and we have L in this equation. So we have to compare the both equation, and after the comparison we can write 1/3 of L naught is equal to L naught under the root of 1 minus v square divided by c square. So we can just cancel L naught in both sides. Now we have 1/3 is equal to under the root of 1 minus v square divided by c square. Now just squaring both sides. And we have 1/9 is equal to 1 minus v square divided by c square. So now just shift 1 into this side, and we have 1/9 minus 1, which is equal to v square divided by c square. We know that the LCM of 1/9 minus 1 is 8/9 minus 8/9. So here we have a minus sign as well, which is equal to minus v square divided by c square. So just cancel minus sign in both sides, and we have only the value of 8/9, which is equal to v square divided by c square. So just cross multiply. So we have 8/9 c square is equal to v square. Now just taking square root on both sides to eliminate the square sign. So square root on both sides. Now we have 8/9 under the root c, which is equal to v. Now just solve the value of 8/9 under the root, and we have v is equal to 0.9428 c. So this is the velocity of spaceship relative to the observer. So this is our required answer.